Good morning. So on screen, you'll be able to see. Hold on, sorry. You'll be able to see the questions that we're going to have a look at today. Okay. So by all means, you can pause the video here if you'd like to work your way through the questions, and then I'll show you the methods, or we can go through a question at a time. I don't mind. Okay. So I'll pull the questions over there, and then we'll talk through. So the first one, 6,545,563. Which number is in the 10,000? It means 10,000 column. Okay. A lovely and straightforward one. Okay. You get something like this, you might well already know the answer, but if you're not sure, I won't do it there actually. If you're not sure, then write the number out. And then start labelling the place value column. So you've got obviously units, tens, hundreds, thousands, 10,000, 100,000, and then million. Okay, and then it wants the 10,000, which is that one, so it's a 4. Okay, so the answer to number 1 is 4. Okay, which number? Now we've looked at that this year, haven't we? Which number? Really, you'd want the language which digit, because the 4-digit, which number? It's 40,000. Okay, if it says which digit, which it usually will, then you'd have the number the digit 4. Okay. Round, is that the same number? No. Round 6,345,952 to the nearest million. Okay. Well, going off what I've just shown you, I know definitely that 6 is in the millions column. 3, 4, 5, 9, 5, 2. And going off what we talked about yesterday, I can actually ignore, because of the question I've been given, I can actually, what's it used to you, is it? Neither is that. I can ignore all of these numbers, these digits, I don't need them. Okay. It wants to know about the millions column, so I look one column to the right, so I'm looking at the 100,000 column. It's a 3, and it will round down. Okay, so the answer is 6 million. Again, if you think about it on a number line, you'd have 6 million there, 7 million there, and you'd have 6,500,000 there. So on there, okay, 500,000. You've got 6,345,000, so you're not at that halfway point. You're somewhere sort of here-ish, maybe a little bit further along, which means it's easier to go this way than it is to round it all the way up that way. Okay, it's nice and straightforward, especially if you use a number line to visualize that. Okay. Ooh, let's have a look. So write in the missing number to make the addition correct. So you've got, this might take a bit of working out for me actually. So you've got blank, 5 blank, that's fantastic writing, add something, 6 is going to equal 600. Okay, so it's a little bit of problem solving here. All right, the first thing that I can spot is number bonds to 10. Okay, so if you look at the answer, you've got a 0 in the units column. Now, I've got a 6 in my units column here, and I need to make a 0. So it's probably 4. Well, it is going to be 4. So that one there will be 4. 4 add 6 will make 10. Okay, so taking that into account, I'm just going to make a note there somewhere that there's going to be a 10 to carry over, because there's a 0 in the tens column as well. So 5 and that are going to make 10, but I've got that 10 to carry over as well. So that, unless I am mistaken, is 46. Okay, and then this must be 5. 554, let me just check, yeah, 554 and 46. Okay, not 400, not 600 on this one here, because I need it to equal 600 overall. And then what I can do with a question like this, I've talked you through my reasoning there, but just in case I've made a mistake, which does happen quite often actually, is I'll use column addition and I'll check. So we do 554, and then we're going to add 46. Nice and simple mistake to make. It sounds really obvious, but make sure that you've got your place value columns correct. If I put the 4 here, then I'm going to get it wrong. I'm just going to make my life harder, aren't I? 6 and 4 is 10, carry the 1. 5 and 4 is 9, add the 1 on, so it's 0, carry over. 5 and 1 is 6, 600. Okay, which is definitely right. I've worked it out myself, and then I've used the inverse. I haven't used the inverse, sorry. I've gone back and used my answer back into the question and made sure. Number 4, Write these in order highest to lowest. So I'm going to write them out myself, just because I find writing questions like this out helps. Because I'm not going to miss anything. 1.34 kilograms. 0.99 kilograms. 100 kilograms. 0.009 kilograms. And 1.034 kilograms. Okay. It wants highest to lowest, doesn't it? And again, go back to the question there. The amount of times I've got a question wrong because I've done lowest to highest and it doesn't want that, well, I'd be a millionaire. Pound every time I got that wrong, and I'm sure I'd be a very rich man. Highest to lowest. For this one, I don't think you need to do any conversions. You don't. You can stick with what you've got. I mean, you might be able to convert this one and this one into grams, but I don't really see the point of that, to tell you the truth. So the biggest is nice and easy. It's 100 kilograms, isn't it? It's the biggest number there. So I'm going to just change my colours, and I'm going to put 100 kilograms there. Okay. Then I'm going to go back to the list, and I'm going to cross it off because I don't need to keep looking at that anymore. Then I've got a choice of 1, 0, 0, 1. So I'm moving along place value columns. Okay. So I've got a 1 in the units, a 0 in the units, a 0 in the units, and a 1 in the units. Well, it's going to be either this one or this one. Okay. 1 is obviously bigger than 0, which I hope you know by now. So the zeros can get put aside for a little bit. So that's got a 1, and then in the place value next, it's got a 3. Okay. This, in 1.34, this is the biggest place value column I've got. It's got the most value, it's got the most moving power, it holds the most weight over the number, I suppose. That's not really what I want to say. It holds the most control over the number, maybe. Okay, and after that, you keep moving place value columns to the right. So that 3 is worth 3/10. If I go down, this number has no tenths. 3/10 is worth more than no tenths, obviously. So it's 1.34. Okay, then I can cross that one out. Okay, then I've already done the work for myself. It's 1.034. Okay, because 1 is still bigger than 0. And then applying the same logic, I've got 0.99 or 0.009. Think about it in pennies if you need to. Would you rather have 99p or 0.09p? 0.009p. So there's nothing in this column. So we go to the column to the right. There's nothing in that one, but there's something in that one. So it's 0.99. And then it's 0.009. And I've just realised as well, get rid of all that horrible working out now. Nothing wrong with it being messy working out, as long as your answer's nice and clear. Okay. So get rid of most of that for you. I haven't put the units on. So I'm just going to squeeze them in. Okay. That's that one. Let me just check I've got that one right. Yeah. I'd be worried if I didn't. But there you go. Okay, question 5. £1.49, add £5 and 3. Okay, £1.49, add £5 and 3. Loads of different ways to do this. You could probably do it mentally. The two ways that I would recommend doing it would be either column addition, £1.49, and £5 and 3, or just partitioning. Okay, so I've set that up for column addition, but for me, I wouldn't use column addition for that one. I don't need to. Okay, so you do the 1 and the 5 for me, so you get the £6, just keep it in your head, and £49, 49p add 3p, add the 1p on to make it 50p, so it's 52p. Okay, £6.52. So just to talk you through that, I'm going to take 1p there and put it there, and turn that into 50p, and then I've got 50 add 2. Okay, so I didn't just jump there out of nowhere, and then it's £6.52. Okay, but again, you get the same answer by using column addition. It's just a bit more writing that you don't need to do. £10 subtract £6.43. I've read that right, sorry. Really easy to make a mistake on this one because you're subtracting over boundaries. Okay. You may have a method for this one. You might want to use a number line or something like that. You might be able to just do it in your head. For me, again, I'd go for partitioning. I'd be partitioning that one up. So let's do £10 and let's take £6.43 away. £6.43. Okay, and just look at how simple this is to do. So you're going to do 10 take 6, okay, which is £4. Then you're going to take the 40p away, which is going to be £3.60. And then you're going to take the 3 away, which is £3.57. Check if I'm right, yeah, £3.57. So just by partitioning that and not trying to do it all in one big chunk, not trying to take the 3p away first, £10 leaves you with £9.97 to then take 40, it just gets a bit messy. They're nice small numbers there, so just work almost the way around that you wouldn't expect to do. 10 take 6 is £4, then £4 take 40p is easy, and then £3.60 take 3p is easy. Okay, they're all simple calculations, but when they're put together, it can cause a bit of trouble. The prime number's up to 20. Okay, so a prime number, some of you might remember, some of you might not. Prime number means a number that is only divisible by two numbers. It is only divisible by 1 and by itself. Okay, so for example, 2. You can only divide 2 by the number 1 or by itself. Okay, so 2 is 1. 3 is 1. 4 isn't, because I could divide it by 2, so that's a no. But notice how I've got a question like this and I'm not just using my memory, I'm checking. I'm thinking, I don't think 4's 1, but I have to prove it. Okay, I get a mark if I get it right. I don't get a mark for best intentions, so I'm checking and I'm making sure I'm getting them right. Okay, 5, you can't by anything. It divides by 1, not 2, not 3, not 4. So 5 is 1. Okay, we go up to 20. 6 can divide by 2 and 3. 7, 8 can divide by 2. You'll notice a pattern emerging as they get a little bit older, a little bit bigger. This is the exception to the rule, but there might be a big rule to prove me wrong somewhere. Every prime number beyond 2 has to be odd, because every even number is divisible by 2, so it breaks that prime number rule. Okay, so you've got 2, 3, 5, 7. 9 is not 1, because 9 is divisible by 3. 10 is divisible by 2. 11 is not divisible by anything, apart from 1 in itself. 12 is divisible by loads. 13, this is where your knowledge of factors comes in as well. If I can give you a number and you know the factors like that, and especially factor pairs, then you'll start to recognise where prime numbers occur a little bit easier. 14 is in the 7 times table. 15 is in the 3s. 16 is in the 2s. 17 is in nothing. 18 is in the 9s. 19 is in, I don't think 19 is in anything. Is it? 2, 4, 6, 8, 10, 12, no, it's not. So 19. Okay, let's just check I've got all those before I look an idiot. Yep, perfect. Okay, but notice there's nothing wrong with 19 throwing me. I put it up there, I work it through my system. If it does not meet those criteria, if it does meet those criteria, then it has to be a prime number. There's no other question about it. Okay. Y equals 3, so 7y equals, you might not have come across anything like this before, but it is dead straightforward. What it's saying is, y is worth 3. Now, if you have something written like this, 7y, there's an operation that fits here. Okay, so you've either got add, subtract, times, or divide. Okay, pause the video there, have a guess at what it is before I tell you, if you want to, or not, I can't make you, can I? It's multiplied, it means 7 times y. So all it's asking you to do, the whole question, as confusing as it looks, just wants 7 times 3, which is 21. Okay. Bit of algebra coming in there. All the factors of 12. Oh, good. Glad that came up. So, well, you're not having my feedback now, are you? 12 for the 3rd time. Okay. Factors are numbers that you can count in to reach the number you've been given. Okay. So if you count in 2s, are you going to reach 12? If you count in 1s, are you going to reach 12? So on. Okay. For me, I've told you this before this year, I would always do them in factor pairs. Okay. Otherwise, you stand the chance of missing one. All right. So for example, I know 6 is a 1. I know 4 is 1. I know 3 is 1. I know 2 is 1. But then I sort of, well, I think I'm done there. Pair them up. What do I want to do that? Pair them up, and you won't miss one then. Okay, and then you get to that tipping point as well, which we've talked about this year. So 1 is a factor of everything because you can count in ones and read every number. So 1 has to have a factor pair. 1 times what is 12? Well, it's 12. 1 times 12 is 12. Is 2? Yeah, because you can count in 2s and get to 12. 2 times 6 is 12. So 6 must be a factor as well. 6, 12. Okay. You can count in 3s. 3, 6, 9, 12, and it's 4. Okay. And this is where you get your tipping point. So you've got 1, 2, 3. 4 is also a factor, but you've already got it. You've already got it on this side, so you've got them all. Okay, and I'll prove it. So you've got 1, 2, 3, 4, 5, 5, 10, 15, missed it. 6, we've already got. 7, 7, 14, missed it. 8, 8, 16, missed it. 9, 9, 18, missed it. 10, 10, 20, missed it. 11, 11, 22, missed it. 12, we've got. Okay, and then obviously 13, 14, and 15 can't be factors because they're already bigger. So that method there gets you all of the factors. Okay, I know I was talking very fast there, but you have done that to death this year. Okay, another good one. Nice bit of practice for you, this one. So you've got 1 and 4 fifths, he says, trying to write with a rubber as usual. 1 and 4 fifths, add 1 and 1 tenth. Okay, now I've tried to get this across in as many different ways as I can this year. You cannot, these don't interact. They can't at the moment. You can't compare fifths to tenths. They're different denominators. Okay, so they need to be the same. But that's not a problem for us. We can convert them really, really easily. Okay, so let me just rub that out because I don't really want that. Okay, so I can convert tenths to fifths or fifths to tenths. I would always convert up. This one's way too hard. Well, it's going to create something abstract. You're going to get 0.5 over 5. Yeah, half a fifth, which is pointless. So we're going to do this one. Okay. How do you turn? Well, you're not going to answer me. You're not going to shout at the computer, I suppose. To turn fifths into tenths, you multiply by 2, so you make it 2 times bigger. Okay. So you do the same to your numerator. Okay. You're going to multiply the 4 by 2, and you're going to get 8. So you've now got 1 and 8 tenths. 1 and 8 tenths. Yeah. Add 1 and 9. Doesn't say 9 tenths, does it? I knew that as I was writing it. Sorry. 1 and 1 tenth. Okay. So you, again, do this however you want. I would do the whole numbers first. So you've got 2. Cross those off. And then you've got 8 tenths, add 1 tenth, which is nice and easy for us. Sorry, the video cut out there. Nice and easy. It's obviously 9 tenths. 2 and 9 tenths. Sometimes with this, you might end up with an improper fraction, so you've got some more work to do to it, but there's nothing to do here. 2 and 9 tenths is a mixed number fraction, but it fits all the criteria that we need it to, so that's fine. And that's all of them done. Okay. So the same as yesterday, on screen within the next sort of couple of seconds. Not right now, just because I've looked at the video from yesterday and I said, appearing on screen now will be the questions, and they didn't turn up, did they? Because that was more work than I thought it would be. Appearing at some point in the next couple of seconds will be a challenge question for today, based on the White Rose Hub maths that you've been doing today. Okay. Pause the video, have a go at it yourself, and then I will come back and I will talk you through the way that I've worked that one out as well. Okay. I'll see you tomorrow. Okay, so you've had a look at the challenge question by now. I've got it up on my screen here, but I know it will be a little bit small for you to read, but it's all right for me. So if you need to, then go back to the question, have a reread of it before you come here. Okay, so using the decimal numbers shown in the image, Orla and Brad are trying to find the closest number to 7.5. Brad says 7.6 is the closest because it's only 1 away. Do you agree with Brad? Explain your answer. So, closest to 7.5, so we're going to put 7, oops, can't write with the rubber, one day there. We're going to put 7.5 here, okay, and then I'm just going to copy down all of the 7.05, I'm just going to copy down all of the numbers, 7.15, 7.55, 7.49, And then I'm going to put this one here, 7.6, and I'm just going to put a bubble around it because that is the one that, what's his name, Brad thinks is the closest to 7.5. Okay. It's a question that may strike you as quite straightforward, but it's one that I see a lot of you making mistakes on. It's one that's very easy to slip up with. There's a couple of ways to tackle it. You might want to use a number line, okay, but for me, I think column addition would be a really good method to use as long as you know your place value columns securely, okay. So I'm just going to make a note of those down here just to help me. So you've got your decimal, you've got your units, then you've got your tenths and your hundredths, and then your thousands, okay. And that's going to become really important in a little bit. So 7.5, we're going to try and add or subtract to each of these numbers and make them 7.5, and then we're going to compare the answers that we get. So let's start with this one. 7.49 is obviously less than 7.5, and I need to add 0 there, 0.01, okay, because 49 add 1 is 50, 7.5 is the same as 7.50, and I'm going to put that 0 in. I don't need it in the hundredths column, but I'm going to put it there because I think it might help the answer become a little bit clearer. I'll do the same there. Okay, so that's 100th I need to add, which is a very small amount. So let's have a look here. 7.55 is obviously past 7.50 or 7.5, so it's a subtract. That one was add. I just have to squeeze it on that side now. Subtract. So I'm, again, forget about the 7 for now. 55 subtract what is 50? Well, that's lovely and easy. It is 0.05. Okay, so this one's still the winner. This one's the smallest. I only need to make a change of 0.01, 100th. This is a change of 5 hundredths. Okay, so have a look at this one. 7.05 is well away from 7.50, so I need to add 0.45. Okay, 4 tenths of 5 hundredths. 7.15 is not at 7.5 yet, so I need to add, and then this is 0.35. Okay, 35 add 15 is 50. 0.15 add 0.35 will be 0.5. Okay, so I'm applying what I know in my tens and my units column, but I'm applying it to decimals. Okay, I'm not learning a whole new language when I don't need to. Now this one is the one to pay attention to. 7.60. What's his name? Billy. Brad. Billy. He can be Billy for all I care. Brad says that is the closest because he says it is 1 away. Okay, 1 what? Kit Kat. 1 Kit Kat away. So if we do the calculation, obviously 7.6 is above 7.5, so we're going to do the subtraction, and it is 0.10, okay, or a tenth. Don't need that 0 there, it just helps. 0.1 is more, well, it's mathematically correct and probably what I would expect you to be doing, but that placeholder 0 is not actually holding any place, it's not placeholder 0. That 0 there is just to show there's no value in that column. Okay. So he is right, it is 1, but it's 1/10. It's not 1 unit, he's just said 1 in the question, only 1 away. So it's not 1, it's 1/10. And he's wrong, because tenths are worth more than hundredths. So this one here is the closest, because a hundredth is smaller than a tenth. If you go back down here, you start with the very right-hand column, because we're going from smaller to bigger. This is the smallest column, then this one, and then this one. So Brad said, is his name Brad? Billy or Brad? Brad has said that this 1/10 here is the smallest jump, and it's not right because I've got a jump of 1/100th. So 7.49 is the answer there. I've rattled on a little bit there, but 7.49 is the answer. And again, I haven't guessed, I haven't assumed. Sorry, go to that. I haven't assumed. I've got the mathematical proof on my paper, well on my screen. Okay. To support. Okay, I hope you got that one as well, and I will see you tomorrow.